Hello everyone, we are Team 24. This is Santosh and my teammates are Shanita and Janani, and I'm here to present our project identifying plant diseases, a classification approach. Here in this project, we have developed a machine learning model that classifies plant diseases with remarkable accuracy. Basically, in agriculture, the health of crops is vital as it directly affects the livelihoods of millions. Fungal diseases like rust and powdery mildew pose significant threats. These diseases not only reduce crop yields but can also devastate entire agriculture sectors. So, our primary goal is to empower farmers by using this technology to quickly identify these diseases, allowing for timely intervention and treatment. And coming to a dataset, we have a dataset consisting of 1530 images categorized into three labels: healthy, powdery, and rust. And through exploratory data analysis, we gained insights into the distribution and characteristics of our dataset that the total of 1530 images are distributed among three plant condition labels with 85% training, 5% validation, and 10% test dataset. And this distribution is balanced and is evenly distributed in order to avoid any bias towards particular class label and allowing our model to train well. And the baseline model we set is a CNN-based model to directly classify the images into one of the three classes. And here initially we did a data pre-processing step using TensorFlow tool called image data generator and rescaled our images to normalize input pixels such a way from converting RGB 0 to 255 values to 0 to 1 values in order to correctly extract features from input image through initial layers in our model. And we fed this input image into a series of three convolution layers and three pooling layers where we increase the size of filters from 32 to 64 to 128. And we have used ReLU as an activation function. And after extracting features from our input image in the convolution layer, and we send this uh, to a pooling layer. So here in this pooling layer, then we are reducing the volume of extracted future size, and say like it reduces the input image sampling to it in order to reduce the overall computation involved in our model training. And this continues through the series of steps. And after that, we applied flatten layer to convert the output of convolution layer to single feature vector array. Nextly, which dense layer accepts this format, where we have set the size of 256 neurons in this hidden layer. And, and next we have added a dropout layer to reduce overfitting, and in the final dense layer with here with exact matching number of neurons 3, which outputs the classes of three labels to the exact probability. And finally, through output layer, we'll be getting our output and predicted results. And here comes our testing accuracy of our baseline model, CNN model, with 92.67%. And coming to the final model, here we choose a inception-based V3 architecture, which is an advanced version of CNN architecture, where we have trained pre-trained data weights comes with a data net, which is used to efficiently train our model. And it also uses inception modules which allow it to look at the same image at different scales simultaneously. Like each inception module has parallel paths with different filters, allowing model to capture information at various levels of abstraction. Here again, before start training our model, we have used data pre-processing technique, the same called data image data generator on top of our pre-trained data weights, which is the key factor here to achieve higher accuracy as the model to train on these pre-trained weights. And it also by default comes with a series of layers, and we can easily train our model across a combination of series of these different layers. And here, after implementing our data pre-processing technique, we finally fed our input image to our model, which then goes through a series of combination of convolution average pooling, and then convolution max pooling, and then convolution average pooling, and then convolution max pooling. So uh, we followed a series of convolution average pooling and convolution max pooling, and finally we have added a custom dense layer and an average max pooling 2D layer that effectively draws output from our output layer. And uh, coming to our testing results, here comes with 96.43% using inception based V3 architecture. Uh, and here you can also compare the test results that we improved training accuracy from 92% to 96% and testing accuracy from 93% to 97% from a baseline model to our final inception based V3 model. And coming to a conclusion, like we tested against multiple models like CNN, ResNet 50, MobileNet V2, and Inception V3 architecture. And finally, we choose Inception V3 due to its higher accuracy and better handling of complex data. And we also implemented it successfully. And our future scope is to increase variety of data set and explore advanced machine learning techniques, and a mobile app can also be developed for real-time disease diagnostics and integrate environmental data to tailor predictions and support sustainable farming. And yeah, that's it. That's it about our project. Thank you, guys.